Earlier, I have showed you how to use the cash flow analysis, the cash flow key to do the uneven cash flow analysis. If you still have some problem, please go over with the sample number 7 in Appendix D. The remainder of lecture we are dealing with now is the even cash flow. So, well, still even cash flow means the future cash flow payment are the same. So we are going to use the time value money again on the third row of the financial calculator. But we're going to using NI, present value, and PMT. PMT represent the multiple future value. But the future value is only one cash flow, but PMT means multiple. So in our case, we do not using FV. FV is equal to 0, but the PMT represents those multiple cash flow. Those cash flow must be equal. A good example of a financial contract is the annuity. Annuity is a finite series of equal payments that occur at the regular intervals. If the first payment occurs at the end of the period, if the payment occurred at the end of the period, we call it annuity, ordinary annuity. I think 95% of annuity are ordinary annuity. However, if the first payment occurs at the beginning of the period, those are called annuity dues. Like apartment rent, car lease payment, those are is called annuity due. We do not study, for this class, we do not study annuity due because there are some problems setting up your financial calculator might get into trouble. So we're going to skip the annuity due totally. Everything we're dealing with here are ordinary annuity. All occur at the end of period. Now, annuities for finance series, 30 years, 15 years, 12 months for the finance period. But if you let the period go to infinity, those annuity we call perpetuity. Since our financial calculator does not have an infinity sign on it, therefore, the perpetuity we have to rely on is a mathematical formula. The value of a perpetuity is equal to payment, the same payment, divided by interest rate. Our textbook using PMT divided by R, some textbook using C, cash flow, the constant cash flow, divided by R. So you have to using financial calculators. Now for annuity, you have to using mathematical formulas. For annuity, we rely on financial calculator, not the formula. The formula is too complicated. Okay, just remember that if a perpetuity, if you do forever using formula, if it is annuity, it's a finite, like 30 years, 360 months, those we use financial calculators. Now let's dealing with the perpetuity first, assuming that the cash flow look like this. C represents cash flows from 1 period, 2 years, 3 years, go forever, go to infinity. So we basically, mathematically, we discount it by each, the cash flow by the cost of a capital, interest rate or discount rate. Also will go to infinity since, this is what we call infinite theories. It converged. When the number go to very high, then it converged to a formula equal to single cash flow divided by R. It's pretty straightforward. This one also is the formula for preferred stocks valuation. Now let's look at example, perpetuity example. What is the value of a British council that promised to pay you £15 each year forever? It go forever, okay? So we're using mathematical formula. Now, if you think about your timeline will be 15 pound, 15 pound, go forever. But the math say that 15 pound divided by interest rate 10%. Here, when you're using math formula, you have to using decimal point, okay? 0.1. So this value of the British Council worth $150. You can think about this one. If the preferred stock, it pay you $15 per year as a dividend, how much you pay for this preferred stock? If your cost of capital is 10%, it worth to you is $150. So it's a very straightforward calculation. Payment divided by interest rate. But this is for perpetuity. Now let's look at non-perpetuity. We have a finite period. We have to rely on the PMT key on the calculator. Okay. Now each payment are equal, the same payment. Now remember that the sign conversions still hold. Think about cash inflow, cash outflow. Earlier I said that ordinary annuity, the payment occur at the end of period. On the other hand, annuity due occurred at the beginning. Most problems are ordinary annuity. The annuity due, I can think of examples like apartment payment, car leasing payment. You pay first, then you use the apartment. Pay first the rent, then you use the car. All the rest of it, just ordinary annuity. Because you have to change the setting, there is a danger you might mess up with your financial calculator, particularly when I'm not monitoring what are you doing. Everything get messed up. So don't do the annuity due. Ignore the annuity due. Okay? So you don't need to worry about how do you set up the beginning mode and ending mode. Remember that if you have some problems, look at your financial calculator screen. On the screen, when you turn it on, there should have nothing on it. If there is a BGN show up, means you are in trouble because you are accidentally set up into a annuity due. So all the payment will off. Okay? So don't do anything on it. Only look at this slides when you see the BGN. We have to set it back to the end mode. Okay? There are a couple of important points to remember at the very beginning. When you're looking at annuity like a loan payment, the payment usually occurs like monthly. Then the interest rate you are using for a monthly payment schedule must be monthly interest rate. So when we're talking about annual period, if each period is annual means per year, semi-annual means 6 months, monthly means 12 months per year. So you have to adjust the annual rate into monthly rate, for example. The sign conversion, remember, cash inflow, usually you use positive, cash outflow using negative. I usually in the present value either using negative. Then payment will be inflow. As long as these two, like PMT and the PV, are opposite, it works. Not necessarily have to be inflow or outflow, but it helps you to understand, because inflow to you for a banker is outflow. Okay, it must be, sign must be opposite, otherwise it won't work. Let's do one example that's working on why the sign matters. Now, you also can draw a timeline. Let's look at the first timeline. It says that annuity is 5 years. Interest rate is 10%. Okay? Present value is negative 100. And payment is 20. Now here you are solving for the fifth parameter, future value. What is the future value is? Here the future value is 38.95. Now here the 20 payment is the withdrawal now. If the 100 is your deposit, right, is out of cash flow, then 20 was cash inflow. So in that case, this kind of plan give you only a value of 38. Now, if look at the second one, if you put a present value as a negative 100, you put a down payment 100, okay, for 5 years, interest rate is 10%. The PMT using negative 20. That means you put additional every year for 5 years, $20. You add. See the sign? Negative, negative. That means first you put a 100, then each year you put a $20. The total value at the end of the 5 year is 283. So here is the add. So make sure that the sign must make sense. Cash inflow, cash outflow. Okay, this is an important concept you need to understand. Let's look at example 5.5. Let's assuming you can afford $632 per month. That's monthly payment. Okay. Now, if the going rate per month for 48 months is 1%, you are given 1% is the monthly rate for 48 months. Right? How much can you borrow? Okay. How much can you borrow? Now, this is basically is the typical loan situation. The present value is the loan value. The present value is loan value. In textbook, they give you a formula and also give you the Excel formula. Let's ignore that. Let's concentrate on our financial calculator. Here I'm using red color. So now the order, how do you enter those numbers doesn't matter. I'm just using 632 is your payment. 1 is your I. Remember, here is always the percentage. 48 is number period. Those are monthly, 48. Let's put a 0 in FV, or you can ignore that because there is no single cash flow there, inflow yet there. You want to calculate what is the present value for that. Now, as a matter of fact, your financial calculator should show you negative 2399.54 or approximately 24,000. Okay? It's a negative sign to show you this loan value. The present value is loan value. Remember, that is the opposite sign of the payment. Okay. Now you can argue payment is what you pay. The present value, loan value, what do you receive? But you see the sign is opposite. Okay? We're using that. Now let's look at another example of annuity. Suppose you win the Publishers Clearinghouse 10 million sweepstakes. They're not going to pay you 10 million once. The money is paid in equal annual installment. So 10 million divided by 30 per year, you get 3333.33. Now this is your financial calculator input for the payment. Payment is 333. This one, payment. 30 is your N. I is your 5. Yeah. What is the present value? In other words, what those cash flows, actual cash flow, worth today? Your financial calculator compute for present value should give you negative 5,124,150.29. Now this is because the equal payment every month you receive that amount. So that one was close to half of it, not 10 million, 5.124 million, right? This is how you calculate its present value. Now next one, we're going to looking at buying a house, borrow a mortgage. Now please read this problem carefully. Everybody need know that. Okay, you know how to do the mortgage calculation. Buying a house. You are ready to buy a house and you have $20,000 for a down payment and a closing cost. Those numbers are kind of very, very early number, probably 20 years ago they're using those numbers. It's assuming $20,000, which including down payment and the closing cost. Now, what the closing cost is the cost you pay the mortgage bank. You're closing the loan. It's based on loan value. It's not the housing value. Closing cost is based on the loan value. Here we're assuming is 4% of loan value. Closing cost you pay the mortgage broker and the mortgage bank. Now let's assuming you have an annual salary, $36,000, let's say pre-tax. The bank is willing to allow you monthly payment to be equal to 28% of your monthly income. The interest rate or the mortgage rate on the loan is 6% per year with monthly compounding or monthly payment. Now the 6% is annual rate. Divide by 12 equal to 0.5. So 0.5 is the monthly rate. That is for a 30-year fixed rate loan. 30-year fixed, how many months we have? 30 times 12 equal to 360. We have two questions. Number one, how much money will the bank loan to you? What is the maximum amount you can borrow from the bank? The second question is, how much can you afford for that particular house? Now, we solving this problem by doing the following calculation. Number one, you need to figure out what is the bank loan amount you can borrow. Your monthly income is the annual salary divided by 12 equal to $3,000. The bank allowed payment is up to 28% of your monthly paycheck. 28 times 8% times 3,000 is 840. 840 is your loan payment. Now, see, we're going to use our financial calculator to do the calculation. A40 is your payment. I'm just using positive there. Number of period is 330 times 12, 360. Interest rate is 60 by 12 equal to 0.5. That's your I. Given that 3, NI-PMT, compute for PV, present value, which is 140,105. If you did not put a negative sign in front of A40, your present value will have a negative sign. Okay? It doesn't matter. It will be sign conversion, opposite sign in it. So that one is 140,105. That is the maximum amount loan you can receive. You will be qualified from the bank. With that in mind, now you can calculate how much house you can afford. First of all, you need to figure out what is the closing cost. The closing cost is the loan amount, 4% of loan amount. So 4% times 140,105, the loan amount, will give you $5,604 as your closing cost. You already have $20,000 in the bank. $20,000 minus the closing cost, $5,604. The remaining is $14,369. Now we use this one as your down payment, plus the loan amount, $140,105. The total price of the house is $154,501. Now the number we are doing it because this is a very old example. Now currently mortgage rate not that high, but might have some change. But this is the way to how do you figure out how do you pre-qualify for a loan, etc. I want everybody go over this problem by yourself. You understand how do you calculate those calculations. Okay. Now, when you loan the payment, if you know the payment amount for a loan, you can figure out what is the loan amount is. The present value is the key element here. Okay, so if you want to receive $5,000 per month in retirement, if you can earn 0.75% per month, and you expect to need the income for 25 years, how much do you need to have in your account at the retirement? Now, in that case, 300 months, right, for 25 years. Interest rate, 0.75%. The monthly payment will be $5,000. What is that? The saving account, or what your retirement account should be, which will last you 25 years. You compute for present value. You discount it for present value. The financial calculator will do that very quick for you. It's negative 595,808.1. Negative means just cash outflow. You're the saving. You have to save it. And you'll receive 5,000, which is cash inflow. You'll receive as a payment. All right. This is how do you calculate a retirement. The next problem is asking you to find the payment. Suppose you know the loan amount is $20,000 for a new car. You need $20,000 for a new car. You can borrow 8% per year, but it's compounded monthly. So your interest rate, let's just do a calculation. We say 8 divided by 12 equal to 0.66. Now, when you do your financial calculator, it only shows 2-digit decimal point after decimal point. So you just do the calculator. Instead of key in 0.6667, so 8 divided by 12, equal sign, whatever the number, punch that in. That way, you will avoid rounding error. Now, if you take a 4-year loan, how many months are we talking about? 4 times 12, 48. So here the input for the 3 input. 48 is your N. 8 divided by 12 equal sign, whatever the number, you punch that in as your I. 20,000 as your present value. I like using negative sign for present value. Then you compute for PMT, which is 488.26. That's the monthly payment. Okay, you find the monthly payment. Now let's look at this time. Is just like earlier we did, the last week we did. Give me 3. The financial calculator will do the fourth for you. Very easy. You have $1,000 credit card loan due, and the payment you own. Okay, payment is $20. Minimum payment $20 per month. interest rate per month is 1.5. How long will it take you to pay off that $1,000 credit card loan? 1.5 I 100,000 as a present value, or you put a negative sign on it. Put a 20 as your PMT. And then remember, it's the opposite sign, right? Computed for N. N is 93.11. Remember, this is the monthly payment. Therefore, the number of period must be month. But 93.11 months is approximately 7.75 if you divide by 12. 7.75 years. This example showed you do not only pay the minimum payment. If you can, pay off the credit card loan as soon as possible. Okay, as soon as possible. Let's look at another example for payment. Suppose you borrow $2,000 at 5%, and you are going to make annual payment of 734.42. How long before you pay off the loan? So what's the loan amount? The loan amount, $2,000. Interest rate 5%, annual payment. The payment is 734.42. You compute for N. Remember, these signs must be opposite, present value and the PMT. Otherwise, the financial calculator will show you error message, error S. Then you have the opposite sign. So take 3 years for you to pay off the loan. Also, you can, given this formula, you can easily define the interest rate. Now remember, here the interest rate must be same frequency, the pay period, okay? Suppose you borrow $10,000. Just a minute, where is it? Suppose borrow. Suppose you borrow $10,000 for your parents to buy a car. You agree to pay $207.58 per month for 6 months. So it's a 5-year loan, okay? But 6 months, 16 months, I'm sorry. So what is the interest rate? The interest rate, you key those in, 60 as N, 10,000 present value, payment 207.59. The interest rate 0.75 per month. Per year, how much is it? We call it APR. You just simply times 12. That gives you annual rate. What is the annual percentage rate is? Okay. All right, here I'm going to skip the part 3, the calculation, okay? We say the annuity deal, we definitely will skip. Let's look at the couple of the symbol we are using for this class. Present value, future value, here interest rate, and also the number of period. We are gonna, if it is a perpetuity, the calculation will be cash payment divided by R. If it's an annuity, we're using financial calculator to do that. Oh, my slides is jumping around for some reason. Jumping around. Annuity, this one we already done. Buy a house, already done. Find the number, this one's already done. Find the rates, already done. Future value of annuity. We're not doing that. Annuity due, ignore it. There are a couple of exercises. You will do quick quiz you can using exercise. Here is All right. Next, we're doing is about interest rate. This section teach you how to do the calculate the effective annual rate. Because of time limitation, I'm going to skip this part, but not totally. I'll give you a concept. What is the effective annual rate is? The effective annual rate, EAR, is the interest rate expressed as if it will compound it once per year. It's used to compare two alternative investment with different compounding period. Now, early when we do our exercise, we just simply times the monthly rate by 12. We call it as annual rate. But we totally ignore the compounding rate. Therefore, the APR is nominal, is not the true effective annual rate. Effective annual rate will take consideration of compounding. You always need to make sure that interest rate and time period must be matched. You cannot compare, different interest rate in month, one in monthly rate, one in annual rate. Monthly period using monthly rate. You have to take consideration of compounding effect. I'll just show you one example. The one example, this is a real world example, from a cash checking, the checking cashing service. Sometimes those long shock, quite popular in all the cities here in the United States. Let's look at if you advance to get $50, they charge you a fee of 8.82, right? For 14 days or for 30 days per month. You get a cash in advance. And the amount of the check actually you due in this case is 58.82. The advance, the money you receive, 50. So we do the calculation based on 14 days. What is the effective annual rate is? Because Congress really forced the lending institution show you what the truth that we call the truth in lending. Now, it's close in 14 days. This is the round. The annual rate, the effective annual rate is close to 460%, extraordinarily high. This shows you those cash checking. It's very lucrative business, right? In certain states, I think 2 states or 3 states in the United States, those are prohibited. But in California, it's still legal. Now, just show you, this is what I just took a picture. With the owner's permission, they let me took a picture. I just want to show my student that. Sometimes the compounding, if you take compounding, to reflect what the effective annual rate can be extraordinarily high for those cash advance. The mathematical formula calculation from effective annual rate sometimes I find it's pretty difficult for our student. Well, you're looking at the monthly, looking at the daily, something. So I'm going to skip that part totally. Okay, APR. Now, next one, from here, I need to talk about the consumer loans. Consumer loan like car loans, mortgage loans, student loan, etc. The payment are constant. In other words, the payment including the interest payment and the principal payment. So that one we call amortized loan. Amortization is the depreciation of a financial asset, like a loan you write off. An amortized loan with a fixed payment, each payment covers the interest expense plus reduced principal. Here I want to show you how the amortization is conducted. Consider this is a 4-year loan. Let's assuming the annual payment, so much easier. N equal to 4, interest rate 8, the loan amounts 5,000. You compute for PMT. The payment is 1509.6. Now, that payment, how many payment will do? We do 4 times. That payment never increase or decrease, same amount. Now, how do you distribute to cover both the interest rate and the reduced principal? Here is the decomposed part. I have to use financial spreadsheet to show you that. At the very beginning, the loan balance is $5,000. The payment, the constant payment occurred at the end of the first year, is 1509.60. That's constant, right? What is the interest payment? We say 8%. 8% times beginning balance sheet. 5,000 times 8% equal to 400. That's interest paid. So 1509.6 payment minus 400, that is the principal paid. Now, what's the ending balance? Beginning balance minus principal paid, you get an ending balance. 3890.4 is the ending balance of year 1, which also become the beginning balance of year 2. Using this times 8%, since the balance reduced, your interest payment also reduced. But your payment, monthly payment, does not change. So 1509.6 minus 311, your principal payment on second period, 1198.37, and using the beginning minus principal payment, you get a new ending balance. So here is the principal payment part is amortization. After 4 years, you amortize the 5,000. And here's the interest payment totally for 8 years, 1038. Now, here I'm going to show you a mortgage amortization schedule. It's also called 90-10 rule. What that means, during 2008 or before that, many people are constantly refinancing. The one thing they find out, how come I borrow my mortgage, paid a couple years, it's still that much, It's still $1 million. How to never reduce? The reason is because the principal is very high at early stage. Most payment goes to interest payment. Very few dollars go to retire or principal. Let's do this example. If assuming your mortgage loan is $100,000, interest rate, annual interest rate is 8%. 30 years, 12 months. So the total number of payment is 360. Payment is 733.76. Now let's look at the schedule of your amortization. The first payment, 733.76. You have to cover very large amount, 66.6 10,767 as your interest payment. Why? Because you have $100,000 balance. The principal amount only 67.09. The majority amount go to pay the interest rate. And your principal balance reduce at very low rate because the total amount is too high. Now, let me jump to almost the last payment after like a 359 payment. You still every month pay 3733.67, but the balance becomes smaller at the second half of your payment schedule. You only pay 9.73, and the majority will go to your principal payment. So the 90-10 rule basically says that the first half of your payment, 90% of your payment goes to interest. Only 10% go to your principal. Second half, the opposite true. 10% go to, approximately, 10% go to interest, 90% go to your principal. Therefore, if you constantly refinancing your mortgage loan, you find out you borrow more and more and more because you don't reduce the loan amount in most cases. People, right, are not doing that. So it's the part of causing the vicious circle. The loan become large and large, right? There is a website called the Bank Rate. It's the banking provide all those mortgage rate. Right? You can look at the amortizing table as such. You can key your in, but you already know how to use your financial calculator. You can try it, to compare your calculation if it's similar to what the example from Bank Rate, the mortgage rate, all those real estate rate, to see your calculation if it's right or not. Remember, 30-year loan, you need a 360 monthly payment, for that. Talking about the early example of a monthly payment, usually is subject to the if you are conforming loans, which is a Federal Reserve, a federal bank, quasi bank, they control. So you have to meet now it's probably 33% of your paycheck. You can go back look at what is the housing price and what's affordable housing will be. Now, this example I like to show my student is the home buying map. Early example, I think the first quarter of 2018 for National Association of Realtors, right, to buy a house. You're looking at the median price of local. Now, obviously, the most expensive one are San Jose area and San Francisco area. San Jose area is the one household paycheck, which you can afford to buy a median price house in that area, is $274,623. Wow, it's that high. That means housing value is extremely high. You have to qualify. Now look at other area, even in New York City, somewhere here, is 103, more than double the New York City, because the housing value is that expensive. Now, San Jose area even growing faster than San Francisco area. Lately, Google announced they are building some campus in downtown San Jose area. That area is going up even further. But just to show you, compared to the rest of the country, the East Coast, even with East Coast, our Bay Area is extraordinarily high. Right. Now here is a summary. Today we have learned. Today we showed you the present value of multiple future cash flow. You can do by longhand, one by one, calculate present value, Or you can using CFI key, cash flow key to register one by one, one by one. When you do the calculation of a loan, the interest rate should be commonly expressed. Usually, when the problem given are usually give you annual base, you have to adjust into quarterly if you pay the quarterly, or monthly, or even daily. Okay, and you need to adjust and do all those adjustments. Remember, in monthly situation like 30 years, the n from 30 times 120, 12 equals 360. 15-year loan, 15 times 12 is 180. Now, the n increase be monthly. Now, the interest rate should divide, not time. Interest go down. If 12 is a monthly rate, it's annual rate, monthly rate is 12 divided by 12, 1%. If the mortgage rate is 6% per year, 6 divided by 12, 0.5. In other words, when n increase, according to how many months, or quarterly, or daily, I go down. N go up, I go down. Don't confuse these two. And therefore, the payment will be a monthly payment or weekly payment. Now, how many weeks per year? 52 weeks. Okay. How many days? People usually using 360 days to calculate. Using financial calculator to solve time value money, if you can, it's a more reliable, particularly when do consumer amortization loans. Just remember, given any 3 inputs, the financial calculator will find the force for you. But don't forget, the sign of PV, present value, and payment are always opposite. I like put a negative sign in present value. PMT become positive. But the textbook is just using cash inflow and cash outflow. In that case, PMT negative, present value positive. As long as these two signs opposite, it works fine. Now, when you're dealing with even cash flow, like a constant mortgage payment, etc., you can using PMT. But if the future cash flow is uneven, is not leveled, in that case, you have to using CF key, right? For the time being, I'm going to emphasize the even cash flow part. Most of my exercise is asking you to calculate using TVM function, particularly loan calculation. We will do that. Now, as far as perpetuity, if the cash flow is even and go forever, in that case, using your formulas. That is for example, preferred stock or perpetuity. Cash payment divided by interest rate. Now you have to do the math. This math is simple. You don't need to worry about too much. All right. Now, there is no midterm exam for this class, so I give you more time to do exercise. But I will give you additional time value money exercise. You use it to test yourself to see how good I am, how good I have learned through this process. When we're solving for those time value money, those are very basic financial problems. How good you are with your financial calculator. I'm going to post a 10 question. Actually, I call it extra time value exercise, and ask you to do it. When you do it, you should first do the homework assignment, okay? After that, to do the homework assignment, you have to turn it in. I will give you feedback. I will grade it. I will correct it. But you don't have to turn in the extra time value money exercise. Just treat it as if it's a kind of midterm, self-correct midterm. Do your best. Fill that in. How do you solve that? And at the end of the week, I'm going to provide you with a solution, so you can see how many mistakes you are making. As I said that before, time value money is an important concept, and using financial calculator and how do you calculate the loan payment, etc., are very, very useful. I hope everyone can practice with a lot of exercise. Those who need really take time. For this class, for time beings, we concentrate on using financial calculator. You don't do any mathematical calculation. They basically just using logics. Give me 3 input. Let the financial calculator do the calculation. They find the 4th. Using time, if the problem becomes complicated, draw the timeline. If the timeline is correct, which you have cash inflow, cash outflow, it basically tells you how to solve this problem. All right. Please check the with your assignment page. There is a one or 2 pages for extra time value money exercise, and use as your some kind of a self-testing way to look at how you are doing. I'll see you next week.